Here's an example of a function where we see the table and we have the situation that Carla puts away a certain amount of money per week. She started out with a certain amount, and how could we figure out what she started out with and what she puts in per week? How can we interpret those two things based on the given table? If we look at the slope or rate of change, we can figure out how much she puts in each week. So we have to figure out what is the slope of this table. Remember, to find the slope of the table, we can use two random points from the table and the slope formula. We have the slope formula of y2 minus y1 over x2 minus x1. So let's randomly choose these points where we're choosing 182 as x1 and y1 and 290 as x2 and y2. So the slope would be y2 minus y1 over x2 minus x1. So our slope is 90 minus 82, which is 8. 2 minus 1 is 1, so 8 over 1. So the slope is 8. So the way we interpret that for this situation, if we're trying to find out how much she puts into her account each week, we interpret that slope of 8 as Carla puts away $8 per week. Now, if we look at the initial value, or the y-intercept, we can figure out how much Carla started with, because the y-intercept is where Carla started without any weeks of saving, or 0 weeks. So what is the initial value, or what is the y-intercept of this table? Well, remember, a y-intercept, we're looking for the value where x equals 0. If we think of that x value as the week of saving and the y value as the amount in the account, we can see where x equals 0. We can see from that first column that the initial value is 74 because y equals 74 when x equals 0. So to interpret that, to answer what's the initial value or the initial amount in the savings account, we say Carla started with $74 in her account. Let's try another example. We have Rob is training for a marathon. He is increasing his run each week. Based on the table, let's answer how much more will he run each week, how many miles was he running before training, and how many weeks until he runs a full marathon, which is 26.2 miles. The first question, when we're asking how much more will he run each week, we're asking per week. We're asking for that change from week to week. We're asking to find the slope. So if we look from, let's use the 2 points 2, 7, and 3, 10, we can use y2 minus y1 over x2 minus x1. We can use 10 minus 7 over 3 minus 2 to get 3 over 1. So we have a slope of 3. So how much more will he run each week? He will run 3 miles more each week. How many miles was he running before training? So before the weeks began, or weeks equals 0, that's asking to find the y-intercept. So we don't have the x value of x equals 0 given to us in the table. So we're going to have to use our backwards slope, or use the slope backwards to find that value. Think if x equals 2 is our lowest x amount, we have to move backwards to x equals 1 and then to x equals 0. So we need to, instead of adding 3 with our slope, we need to subtract 3 twice. So subtracting 3 from 7 will give us 4, and subtracting 3 from 4 will give us a value of 1 mile at week 0. So the y-intercept is 1. So that means he was running 1 mile before he began training a week. Now, because we know this information, we can then predict or find out how many weeks until he runs a full marathon at 26.2 miles. So we now need to continue the table on, since the table tells us at most after 7 weeks he'll be running 22 miles. So now we continue that slope of adding 1 week at a time. We're adding 3 miles. So think after the 8th week, he's going to run 22 plus 3, which is 25 miles. And then, so we're still not at 26.2. He's still not ready after 8 weeks. But then if we do 9 weeks, if we add 3 again to 25, now we're at 28 miles. So we've now passed and achieved the 26.2 miles. So after the 9th week, he'll be able to run a full marathon. So to answer our questions, again in summary, he will run 3 more miles each week. He began before training only running 1 mile a week. And it will take him 9 weeks until he runs a full marathon of 26.2 miles. And we found out all that information just by looking at the table and the slope and the y-intercept from the table. Just to make sure we really understand what we're talking about here with tables and interpreting the slope and y-intercept, let's look at one more example. We have Luke wants to buy cookies online for $12 per box with a flat fee for shipping and handling of $4. So for this example, what is the initial value Luke will have to pay? When we're told to find an initial value, that's our clue and our keyword to look for that y-intercept. So that's when x equals 0. And we can see in our table we don't have x equals 0. We have x equals 1, 2, 3, 4, 5. So we would have to find that lower amount, x equals 0. We have to use the slope or the difference in the x and y values to move backwards. Because you have a change of 1 for your x values, you can just subtract 1 from that x equals 1 value to get x equals 0. Now, what would you subtract from the y's? Well, if we're going from 16 to 28, if we're going from 28 to 40, 40 to 52, 52 to 64, well, that means we're adding 12 to each y value, or the change in y values is 12. So working backwards, we're going to subtract 12 from 16, and we're going to get 4. So our answer should be that Luke will have to pay $4 as an initial value. But notice in this scenario that the initial value we just found was $4, but however, in a real life scenario, one does not pay for shipping and handling if nothing is being bought. Think, if you have 0 boxes being bought, you're not going to pay any money. So you have to be careful with your interpretation so that it makes sense for the scenario. Even though the y-intercept of this table is 4, our actual answer would be that he's paying $0 as an initial amount if he's buying 0 boxes. So just be careful where the math meets the real life application and how you're interpreting the slope and the y-intercept.